Hi, to my esteemed viewers, welcome to Construction Quantity Surveying Tutoring channel, where we get to learn quantity surveying. Today I would like us to learn how to take off reinforcement bars for multi-story building in the beams. Okay, you want to learn how to take off or measure reinforcement weight in beams. Presented alongside is a typical beam that has already been casted for slab, where it has been cast already. So what you normally do, you have to interpret your drawing. You have to identify which kind of bars are there, the number, and so on. Over the past few times, we've been referring to this very plan so that we use it to estimate the beams and estimate all the elements that are involved. Beams, this is what we call the beam layout. So when you want to take off the beams, refer to the beam layout. Okay, sometimes it might be combined with the slab layout, but in other cases it might be dealt with independently, as in it might be drawn on its own. For instance, in this case we have this as a beam layout. Then you can interpret your drawing, which is very, very crucial, because if you don't know how to interpret your drawing, then you are in for a long day. Typical floor slab and beam layout. So this is the beam layout that you need to refer to when you are estimating for the beams, for the reinforcement bars. Okay, so what you do, identify where those particular beams, how they have been identified, identify how they have been, the names they have been given, and then you prepare what you call a beam schedule. So a beam schedule is basically you identifying that we have beam TB1, they are of this size, and this is the length that they have, and so on. The reason is, alternatively, you might want to get all the lengths of the beams that are here at once and then deal with them in that manner. But that sometimes is misleading, because you might find that the beams that you're having, they got different reinforcement specifications. So when that happens, then if you combine them together, you're going to have a figure that is wrong, because you're going to have a figure that is showing you that you should be having specific type of reinforcement, yet they are different. So that is why you need to stick to the identification which the beams have been given. Okay, for instance, if they are beam TB7, TB2 as they are shown here, stick to that identification, classify your beams together, and then take off them in that manner. So that is the basic way that you do it. Okay, so let's get to work. So from what we have beams in various directions. These beams, we had done them previously in while we were doing the concrete for the beams. Therefore, what we'll do, from the work that we had done, actually this is where it is. From the work that we had done, we had got the chance to indicate all the items that we have. Okay, so the basic approach in which you would use to easily take off the reinforcement bars for the beams is, one, the step that I've mentioned, identify, find out the beam layout. That is one. Then two, identify the lengths of the various beams that have been provided. For instance, in this case, the beam layout is here. Okay, in this beam layout, identify which kind of beams do you have. Speaking of so, when we are doing the estimation for the concrete, those same lengths are the ones that we are going to adopt, because they have already been done in identification of the various classifications of the beams that are available. Okay, so in the previous work, while we were doing the reinforcement for while we were doing the concrete to the beams, we were able to identify a beam schedule where we had various lengths of the beams that we have. Okay, and the classifications, and that one is just presented here. So for the new, if you are new and you are dealing with a fresh set of drawings, then this is what you'll do. Just find the classifications of the beams and the lengths. So the same length that you had used for calculation of concrete, is the same length that you need to adopt while you're doing also the reinforcement, and I will show you how to use that and get your reinforcement quantity very easily. So once you've done the concrete for the beams, stick to that those measurements and stick to those classifications to do your reinforcement to those beams. Okay, you don't need to start afresh. So this is what we'll do. Once you have the lengths, like in this case you can see there is ID, there is size, there is the number, and then there is of course the length. This length is what we are very much interested in. There is length here, so you can always identify the lengths of those beams as you can from the layout. So these lengths, let's see how we are going to use them. Then after you've identified the lengths, go to the details. Okay, of course you'll realize that they might be having different reinforcement and so on. So go to the details. Once you're at the details, identify those sets of beams that are having similar reinforcement classifications. Okay, and then add their lengths together. That is how you're going to sort those particular beams and do their reinforcement. Okay, so for instance, this is TB1. Okay, so to stick to my format, the way I was doing my the beam schedule at first, I will go with them in that order, so that once I'm done with the TB9, I go to TB10, TB7, and so on. Alternatively, what I can do, I can start with let me just have a reinforcement here. Alternatively, I can insert a column that is indicating, for instance, let me see, this is TB9. Let me just zoom it out a bit so that I'm able to see well. So there is this column that is blank, which is a plus. Because the shorter one, I mean the links are going to be typical, of course. The main bars is where the difference is. Okay, so I want to insert a column here. Just this is still the column, the beam schedule that I made while doing the concrete to the beams. You can see that. Okay, if you have not made one, then you can prepare one as well. So I want to identify. You can see here there is one type of reinforcement that is already indicated here. Okay, so what I'll do, I'll indicate this is a 2 T12, 2 T12, and then 2 T12. So what that means is that the types of beam that I'm going to indicate here are the ones that are having 2 top 12 and then also 2 T12 at the bottom and 2 T12 at the top. Okay, so that as I classify those lengths, I already know the main bars that are in those particular beams. Of course, the links are going to be identical. They are all T8. I've looked at that as well. So the 2 T12 and the 2 T12. So whenever we have such, we are going to let me just take this away. I can cut it there. Okay, then I go to, this is a TB1, so I can search where TB1 is until I shall have indicated all of them. So TB1 has got 2 T12, 2 T12. Okay, then I go to TB2. TB2 is 2 T12, 2 T12. TB2 is having the same, so I just drag it here. Okay, I'm identifying the main bars for the beams. Then I'll add those lengths for the ones that are having the same type of bars. Okay, so I've done for TB1, TB2. Okay, then this is TB3. TB3, let me see the section for it. This is the section for TB3, and you can see it's indicated. We have there are three drawn bars, and it's a 3T16. Okay, and if you look at the section for TB3 is this at the top. It's 3T16, so it's a 3T16 at the top and at the bottom. Okay, so we'll use that. This is a TB3. Let's get it from our schedule. This is it. So we just paste it here. In this case, there are three number, not T12 but T16. So we have there T16, and we also have here actually T16, not T13, and this point is also three number T16. Okay, so we go on. The next set of beam is this is TB4, 2T16, 2T16. Okay, yes, TB4. We have just copy this here. So there are it's 216. This is also 2T16. Okay, then we go to TB5. The same thing, 2T16, 2T16. We copy that, and then TB5 is here. We copy it here, 2T16 and 2T16 at the top and the bottom. TB6 is here, the same. We also do it there. Alright, then we carry on. This is TB13. Here we'll find the rest. TB13 is a 2T12, 2T12. So we copy the one with the T12 and then look for TB13. It's here. We copy it there, and then we go on and on. This is TB14. TB14 to 16. TB14, we look for 2T16, and then we paste it here. Okay, that is 14. This is now TSB1. Okay, TSB1 is here, and reinforcement. You remember this beam, I just need to emphasize, I mentioned that it's 150 millimeters thick, and it's within a slab which is also 150 millimeters thick. So it means there is no extra quantity of concrete for that beam, but then there is a unique set of reinforcement bars for that beam which need to be taken off as well. So in this case we have 4T16, 4T16. Okay, that is a TSB1. So in this case we have got 4T16 and 4T16 there. Alright, so far so good. Let's see what next. The next beam is TB8. Let's see TB8. TB8, the detail is here. These are 2T16 TB8. They're T16 each. Can copy that, and then look for TB8. TB8 is here, then paste it there. Yes, the one that is left is TB11. Okay, this is TB7. Can work with this. For TB7, these are yes, you can see there is a 2T16 at the top and 2T12 at the bottom. Okay, so TB7, yeah, it's here. You can paste this, but you can see at the top is a 2T16, while at the bottom is 2T12. Okay, So that is how unique the reinforcement can be. You can find at the top you have different sizes of bars, at the bottom you have different sizes of bars as well that need to be taken into consideration. We've done TB8, there are a few remaining. TB9 is T12 to the top and T12 to the bottom, two of them. So TB9 is T12. Where is TB9? TB9 is here. So we need T10, TB10 that is. TB10 is 12, 12 as well. That is TB10. It's T12, T12. Alright, then we go to TB11. Let's see TB11. This is 10, TB11 is here. It's 2 T16 at the top and 216 at the bottom. So let's see TB11. TB11 is 216 at the top and 216 at the bottom. We have TB12 yet to do, and that is T16. TB12 is here. T16. We have done 11. Apparently we have 2 11s. Okay, so we'll just copy that and paste it here. You can see we have 2 TB11s, and that is the end of it. So identify the lengths. That is step 1. After you've identified the lengths and you've classified the beams, then now classify the main bars that are there, because the links are of same or similar diameters, but then you cannot say the same for the main bars. As you've seen, we have main bars that are different in sizes. Even in one beam they can be different sizes. So that is step 1, very crucial step, done. So once you've done so, then I would like us now to add. So we'll go to T12. Okay, we'll start with the T12. So at the schedule of reinforcement, let's go to where we did, this is reinforcement superstructure columns. Okay, so we can have it here, reinforcement beam, just have a simple heading, beam reinforcement. Okay, so the one we are going to start with is T12, because we've already identified the various parts where they are. So we'll indicate here T12, then T12. So just indicate the size. Okay, once you have the size, then the diameter of course is 12 millimeters. Okay, then the number of those bars, the number of the bars, and then the length. So let's see what's the number of these bars. But then between having the number identified and having the length, we'd refer to, there are various numbers. Of course, you can see from the beam schedule there are those beams of various numbers that are there. But then I would prefer that we go straight to the length. We get the total length that we have, multiplying by those various numbers. Okay, what I mean is that I would like us not to use that part for the number, because it's not obvious, they are not similar. We are going to assort it. We are going to add those various beams together. So I will go to the length. This is the column for the length. Under the length, I will say equal to, then I get back to where we have done them. This is it. Okay, in this part we have length, and then we have the number. Okay, then let me just confirm one thing here. In this point we were getting the length for 1. Okay, these are length of 1. Okay, let me just confirm it here. So let's take a minute to understand our schedule. In our schedule we have the number. These are the similar number of beams that we have in that particular part, and then we have the length. So In understanding our schedule, we have the number. Okay, so in this case the number implies that we have, this is a TB9, there are 2 of them in the layout, and then the length is just the length of one of those beams. Okay, so that would mean when we need to get now the total length for the reinforcement bar, we'll get the length of one beam. Okay, then in one beam we have 4 number reinforcement bars. Okay, that is two at the top and then 2 at the bottom. So we'll take length for one, multiply by the number of reinforcement bars in that beam, then multiply by the number of beams of similar characteristic. Okay, that is very crucial to understand. So this is where we have the length. Okay, just introduce that title there. This is where we have the length. So the one to start with is the one at the top here. So we'll get the length, that is the length of just one beam. Okay, then in one beam we have 4 number bars, of all of them are T12. Okay, so this is 4 number bars, and then how many beams do we have? In that case we have 2 number beams. So that is a set of 1, which is of T12. Then we go to the next, we'll repeat the same thing that we've done, get the length of 1, then multiply by, this is 2 plus 2, 2 at the top and 2 at the bottom, that is a 4 number. Okay, and then you multiply by 2 number of beams. Okay, step by step, then you go to the next. In this case TB7, we have got 2 T16 and 2 T16, so the length is 0.8 times how many bars do we have? We only have 2 of T12, so multiply by 2, and then you multiply by the number of those beams, plus go to the next. In this case we have 2 T12, 2 T12, so we get the length of one beam, multiply by 4. Okay, 4 at the 2 at the bottom and 2 at the top, and then you multiply by the number of those beams. Okay, then you add. The other case, it's the same. This is 4.1 times now 2, because we only have 2. Actually we don't have T12 there, so we are not going to include that. So let's do away with that bit. So we skip that, we go to the next. The next we have another 2 to 16, 2 to 16, 16, 16, until we are here. Okay, just be keen while looking through that until we are in this one here. So we've got that times 4 number, that is the number of those reinforcement bars, then times the number of beams. Okay, then you add on to the next as well. This is then times 4 times 2 number beams, then you add this is 16, 16, this is 16, 16, 16, 16, 16. Okay, let's see if at all there is anything that we are missing out. Doesn't look to be. Yeah, seems we are good up to there. So once you have that, I will bracket, because this is the total length. Okay, as usual beams have overlaps, of which is not always very easy for you to identify those sizes of those overlaps while you have this type of while you have from the layout as it is. So unless you're provided with what you call a bar bending schedule, it's not easy to tell the sizes of overlaps for all the beams. So that is why we normally allow for a percentage to cater for those overlaps across all the beams that you have. For this being a moderately larger building, so to say, we'll allow for, you can always allow for about 10 to 20% of those particular lengths to cater for the overlap. So in this case I will give a percentage of 10. Okay, so I'll take the total length that I've already calculated times 10%, so it's 1.1. okay, equal to, so while I have that, that's giving me now the total length for all the T12 bars. Okay, therefore the rest of the items to be done is very easy, okay, because this is now just going to do the kgs, and for the kgs, what you do, kgs is equals to diameter squared, okay, diameter is 12 times another 12, and then you multiply by total length, then you divide by 162. Okay, so that is pretty easy. Just take d squared, 12 squared times the total length, then you divide by 162. So that is the T12 that we have got. That is the kgs for the T12. Okay, the next bar is T16 that we are doing here. T16, the diameter is 16, but then now I want us to get now the total length of those particular particular bars. So basically we'll repeat what we've done to get the T12 equal to, okay, equal to let's start from this first one, T12. Okay, so the very first one is the TB7, which I'll take the length of one beam, times, now we have two of them, only two at the top, then we multiply by the number of beams, we add again, the next, this is 12, the next is 16, so the length is here, that 4.1 multiplied by 2 multiplied by 4, actually, yeah, 2, so that is 4, and then times one beam, then we add, the next is here, multiply by 4, 2, then we multiply that by 2, okay, then we add, this is also another set of 16, so it's the length of 1 times 2, that is 4, then we multiply by the number of beams, which is 1, then we add, the next is also 2, so this is 3.9 times 4 bars, times the number of beam, then we add, the next is 12, then we have here 4 T16, so we take 2.6 times now 8 bars. How many of them are there? We only have one. Then we add, this is 3 T16, so it's 5 point, this is the length, times now 6 bars. How many of them are there? We have 2. Then we add, this also 5, 2, that is now 4, then we multiply by the number, then we add, this is the length, this is 2, which is giving us 4, times 2, then we add, the other one is also C16, so that is that, times 4, times 1, then lastly we take, this is also 216, that is 11, times now 4 bars, times 1, okay, that gives us a total, that is 306. So as usual, we do a bracket there, we do a bracket. Okay, so what I want is to multiply this by an adjustment for the overlaps of 10%, and we have it 337, that is the total length. Okay, now the weight therefore is going to be what we have, that is now diameter squared times the total length divided by 162. So we already have, from this we only had the T16 and T12. and of course now the other one is a T8. Okay, T8 are the links. So for the links we need to get the number now, the number of those bars. Therefore we go, this is now 8 millimeter for the diameter, and then the length, therefore it's going, let's get the length of one bar. Okay, so how do we go about that? The length, the difference between concrete for the beams and reinforcement bars for the beams is that concrete is measured below the slab of the beams, below the slab, the level, that is, for the depth, unlike the reinforcement that is now measured all through. When you look at this, for instance, you find this is TB5 and it's identical to the rest of the beams, what I want to explain. This is the link where my cursor is. That dark line is showing the link, and of course the other four are the main bars that we've just measured. For the link here, you notice that this link is going up to the slab. The 150 that is at the top is for the slab, but then we still have that link within that point. So it means you're going to consider the 450 as a whole, not the 300 the way we did while we were measuring for the slab, for the beam concrete. So what that means, what did we have for the cover? That is what we need to confirm. Cover for this beams is 25 millimeters. Okay, so it means get to this detail, and then from the 450 then we will be subtracting 25 here and 25 here. Just follow with my cursor. So that means it's 400, and then to this shorter side, that is now to the width, it's going to be 200 minus 50, that is 150. So 150 plus 400, 150 plus 400 gives us 550. So we'll take 550, that is now the length, is equals to, that is 0.55, then we'll multiply that by 2 for the total length, and then we'll add the hooks. Hooks, in this case the beams are quite bigger, so we'll allow hooks of 100 millimeters times 2. Okay, in that case, so we have length of one link is 1.3 meters, but then also we need now to get the number of those links. So for the number of the links, this is how we do it. So we'll bracket this, and when we do, now this gives us just the length only. Okay, and then we'll multiply by the number. So for us to get the number, we already have the lengths of actually these are lengths of bars, which is giving us the length of the bars, but then what we need, let's see if we need the length of the beams, not length of the bars, because you remember in one beam we are having like 4, sometimes 6 number of bars included there for the main bar, so we can't use that length to get the number of the links. So instead, let's see if we have, right. So what I'll do, let me just undo this so that my length of one link remains constant. But then I'll go to the this is the beam schedule, and I'll go to this. Let me confirm if this length is for 1. Okay, so what I need to insert a column here and then get the total lengths. Okay, so in short, what I'm doing, I am now this is the total length, so I'm getting the number of the beams, or rather the length of one beam times the number of beams that you have. Okay, so basically you need to get the total length of the beams all in the plan that you have, and then you add them. That is what I'm trying to do. And basically when you look at the sizes, you can see this is Okay, only this is the one that is 400 by 150, yet the rest of them are 450 by 200 in size for the beams. You can see this is for 50. If you look at this, is also for 50 by 200. So the sizes are the same. So when the sizes are the same, then it means the length of the links that we're going to use are also typical. So there is no need to, and there is no cause of alarm for in that case. So this is the total length that we need to add. So we get equals to, then we get sum, double click, okay, then you drag your cursor that way until the end. That is it. So the total length of all the beams that you have here is 103. So once you have that, then I wanted to multiply this times now the total length of the beams divided by 0.2. 0.2 is basically 0.2 is the interval, okay, is the interval of the beams. You can see this is 19, 02, 200. So the last 200 is for the interval of those reinforcement that we have, the links. So this is going to give us what we call the number of the links, okay, number of the links. And then of course in this case we don't need to add, or we don't need to multiply by the overlap or any other percentage. And the reason is you realize that we've used the total length. However, there are those intersections where we are not going to have those links for the beams, okay. Therefore the whatever that we're going to find is going to be already adjusted for whatever additions that we might be having, okay. And what I'm saying, you see, for instance, in this particular beam, this is a TB3, the 19, 02, 200. You can see what we have for the links is starting. This is the intersection where we have, for instance, we have grid 1 where another beam or a column is passing through, okay. In that case, we don't have the links inserted or the links installed. So it means when we take the total length just as it is, we don't need to add for any other percentage for the overlaps and so on. If anything, there are no overlaps for the main for the links, okay, but there are hooks, of course, while you are tying those particular bars. So we've got this is the length of one times the number of links that you have. That should give us the total length for those particular for that particular link. So when we do that, we can get the kgs in that manner. So all these is giving us the kgs for the beam reinforcement for one floor, okay. But then we need for all the floors, which are 5 in number, so we'll just take the kgs for one, then multiply by 5, okay. So that is how it goes. Alright, so that was very interesting, and I'm confident that you've also learned from your side as well, and you've learned something on beam reinforcement and how to go about it. So thank you very much, and I'm confident that you've learned. So moving forward, we'll also see we'll get to another very interesting bit, that is now reinforcement to staircase. That is also a very interesting bit that you can't wait to learn from this channel. So thank you very much for watching up to this point. Thank you for the returning members. Word can't appreciate you more, because you are what keeps this channel going, okay. I've seen the number and I'm quite impressed with it, and it's because I'm confident that you are really learning much from this channel. Please share, feel free to share, like and comment. Help the channel grow, and at the same time share so that many people can also learn from what we have here. So thank you for the new members. Please subscribe to the channel so that you also don't miss any of the upcoming videos. Have a great time till we meet again in our next session. Bye bye.